Ever wondered how dispersed dyes are classified based on energy classes? Well, dispersed dyes are a unique class of non-ionic dye known for their low water solubility. Intriguingly, they exist in water primarily in a highly dispersed state. And how do they achieve this state? It's all thanks to the effect of something called a dispersing agent, which plays a crucial role during the dyeing process. Now that we have a basic understanding of what dispersed dyes are, let's delve deeper into how they are classified based on energy classes. Dispersed dyes are classified into 3 energy classes: low energy, medium energy, and high energy. Let's delve deeper into each one of these. Starting with low energy dyes, also known as E-type. These dyes are characterized by their low molecular weight and low polarity. This results in a high dyeing rate, but they do have a drawback. Their sublimation fastness is quite low. Sublimation fastness refers to the resistance of the dye to evaporate when exposed to high temperatures. Moving on to medium energy dyes, or SE-type. These dyes sit in the middle ground with moderate molecular weight and polarity, leading to a moderate dyeing rate and sublimation fastness. They strike a balance between the low and high energy dyes. Finally, we have the high energy dyes, known as S-type. These have a high molecular weight and high polarity, which leads to a slower dyeing rate but a high sublimation fastness. They are less soluble in water but offer excellent resistance to evaporation under heat. The energy class of a dispersed dye is determined by its chemical structure and molecular weight. Low energy dyes typically possess small molecules with few polar groups, while high energy dyes boast large molecules with many polar groups. This difference in polarity affects the dye's solubility in water. Understanding the energy class of a dispersed dye is crucial as it directly impacts its dyeing properties. But why does the energy class of a dispersed dye matter, you may ask? Well, it's all about the dye's properties and performance in the dyeing process. Imagine a low energy dye with its small molecules and fewer polar groups. It boasts good level dyeing properties, rendering it an ideal choice for a uniform, consistent color. However, it falls short in terms of sublimation fastness, which means it's less resistant to the high temperatures of heat treatments. Now, picture a medium energy dye. It strikes a balance with moderate molecular weight and polarity. It provides good level dyeing properties and fares better in sublimation fastness than its low energy counterpart. Lastly, envision a high energy dye. Its large molecules with many polar groups result in a lower dyeing rate but offer outstanding sublimation fastness. This makes it a reliable choice for applications requiring robust color retention under high heat. Therefore, understanding the energy classes of dispersed dyes is key to determining their suitability for different dyeing applications.